Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we check out systems of linear inequalities. Today we're going to be in the Common Core Math standard of functions, and we're going to define, evaluate, and compare functions mainly having to do with inequalities. And our guiding question today is how do we find our solution with a system of linear inequalities? We've looked at a system of linear equations in the past and we've found solutions, and we've also checked out some linear inequalities. Now we're going to put them together and figure out where is our answer with a system of inequalities. And we get to color even more today in math. Pretty cool, huh? Notice we've got one linear inequality here and another one there, and we got this pretty purple. Now we add the red and the blue, put it together. Red and blue make purple. Alright, so we get the color. Let's do it. Alright, we're going to be putting almost together today. We've got two almosts, put them together, and we get something unique. We get a smaller section that is created when we put two linear inequalities on top of each other. Are these solutions? First of all, let's talk about whether this is a solution to our system. Is the point -3, 2 a solution to the system we have here? Y is greater than x plus 1 and y is less than or equal to -x minus 1. So, well, if we have to figure out it's a solution, what we do is we take this x value, plug it in there and there. We take this y value, plug it in there and see if it's true here and it's true there. If it solves both of these and it's a true statement, then we're good to go. It is a solution for that system. Okay? So we put the values into each of them, see if it's true, and here's what the first one gives us. -3, plug it in there, plus 1 is -2. Alright, and then we plug y in as 2. Alright, so is 2 greater than -2? You bet it is. There it is. So 2 is greater than -2. What about this one? Now we plug in -3 into x here, and don't forget there's a negative in front of it, so it's a negative of a negative, which is a positive. And so we get positive 2 is positive 2 less than or equal to positive 2? Well, yeah, it's either or, okay? It can't be both, but it's either or. So 2 is equal to 2. So bam, -3, 2 is a solution for the system. It's in the doubly shaded region. Does that make sense, like we looked at the beginning? So -3, 2 is a solution. What about this one? 5, -2. Is that a solution for this system? For this system, y is less than x plus 5, and y is greater than or equal to 2x minus 9. So we're doing the same thing, okay? Taking that x value, plugging it in, taking the 5, bam, put it there. So, is 10 greater than -2, or is -2 less than 10? Yes, it is. Now, let's plug it into this one. Is -2 greater than or equal to 1? No, last I checked, it's not. So, just because it solved this one doesn't mean this one was true. So it's a solution to the first inequality, but not the second. So it's not in that purple region. It would say be in the blue region only, not the red section. Okay? So just because it's a solution for one of them doesn't mean it's a solution for the total system. Okay, so 5, -2 is not a solution for this system of linear inequalities. All right? Now what we're going to do is talk about how do we write the inequalities given the graph. Here's our graph. All right, this space is the solution right here, this purple section. And so what we want to do is we want to describe this graph first. Well, I'll give it to you ahead of time so we can talk about it. It's y is greater than -x minus 3. Well, how did I figure that out? Well, first of all, you want to find the equation for this line, this blue line right here. Well, the y-intercept is -3, so for our b, we plug in -3. Our y we just put right there. And what about our slope for the x? What is our m? Our m is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So that's a -1. So it's -x minus 3. Okay, that's the first part. So ignore all the shading and everything else. First thing you're going to do is just take a look at that line. Okay? And then from there, you look and see, is it dashed or is it solid? Well, it's dashed, so I put the no equal sign underneath, and then notice it's shaded above it. It's above the line. So y is greater than. Remember, it's not greater than or equal to because it's a dashed line. So it's y is greater than -x minus 3. That's the blue line. Okay? Now, the other line is this. y is less than or equal to x plus 3. Again, find the red line. That's the line you're looking at, and that's what we're going to start with. Our slope is up 1 over 1, up 1 over 1, so it's just a 1 in front of the x, and then our b is 3. That's the easiest thing to find because it hits the y-intercept at 3. Now, we're shading below it, and it's a solid line. Below means it's less than, y is less than, and solid line means it's equal to. So these two inequalities have a solution here of this purple section, and that's what you're going to shade in right there. So if you want to go backwards, that's the idea. Remember, find the line, find the equation for the lines first, then figure out, are you shading above, below, is it solid, or is it dashed? Now you get to try it. Try this one. Remember, find the equation of the line first. All right. Check out if it's below or above, if it's dashed or solid. And ready for your hints? Remember, this is your answer right here, the purple section, and here are your answers. What does this system look like? Remember, that space is the solution. Here are your answers. Y is less than negative 3x plus 2, and y is less than or equal to 2x minus 1. All right. Now, why don't you try and graph these systems of inequalities by yourself? And what I want to check, I want to make sure that you know here that we've got x is greater than negative 1. How would you graph x is equal to negative 1? Well, x equaling something is a vertical line. So what you're going to do is go to negative 1 and draw a line, just like that, okay? So then you're going to shade either above or below, where x is greater than, so you're going to shade over here. And it is not equal to, so you do want to make sure that it's dashed. Does that make sense? And where this one is, it's y is greater than or equal to 2. You'll again go to where y is 2, put the line, bam, there you go. Then you shade where y is greater than, which is above. X is greater than, bam, so your answer is going to be right here. Okay, that's your answer. Does that make sense? That one's a little tricky, a little bit different than what we've seen in the past. All right, ready for your hints? If you're having trouble, definitely go back and rewind it a little bit and see if you can figure out how you're graphing and how you should graph it. You always want to graph it with the y equals mx plus b. Remember, if I give it to you like this, you're going to want to change it around, okay? And don't forget what we've looked at in the past when we've done a system of linear equations, is that if they have the same slope and different y-intercepts, remember they're going to be parallel lines. All right, well, here are your answers. This is the amount that he would need. Okay, right there. There's your answer there, your answer is there. And remember, these are two parallel lines, so your answer is actually right that stripe, right in the middle there. Pretty cool, huh? All right. Well, that's it for today as we talked about finding solutions with a system of linear inequalities. Can you do it? I bet you can. Thanks for joining us as we did talk about systems of linear inequalities. This was Matt with mathsmath.com. Check us out on Facebook at Solving Maths Problems or on Twitter at mathsmath. And enjoy math and coloring, finally.